Alright, let's say we want to find this total area of this shaded region. There's a couple of things you can see already. First, you can see we're going to have to use some type of substitution, and also we're going to have to break this into two pieces because we're going to have negative area and then positive area. So basically what we want to do is get this area, absolute value it, and then add it to that area. So our integral looks like overall from -2 to 2 x times the square root of 4 minus x squared dx. But again, we want to break this up into pieces. We want to go from -2 to 0, because that would be this bottom area of x square root of 4 minus x squared dx. And of course we're going to absolute value that and then add the area from 0 to 2, which is this area right here of x square root 4 minus x squared dx. Alright, so to do that, let's first do our substitution, where let's let u equal what's under that square root, 4 minus x squared. So then du would equal -2x dx. Well, as we can see, all we need is an x dx, so we can move the -2 to the other half, to the other side, by dividing it. So in other words, -1/2 du equals our x dx. So that's the piece that we're going to substitute. Alright, well, now let's just change our limits of integration. And if you don't know how to do this, we did this on the video prior, where if my x is -2, and we're actually looking at this one here, so if x is -2, and I plug -2 into 4 minus -2 squared, which gives me 4 minus 4, or my u equals 0, and then my upper limit, x equals 0, then my u is going to simply be 4, because 4 minus 0 squared gives me my 4. Alright, so what that is that becomes my new limits of integration. So going back from here, I can rewrite -2 to 0 x square root 4 minus x squared dx with my substitution -1/2 from 0 to 4 of u to the 1/2 du. So notice all I did here was I substituted my x dx for my -1/2 du and substituted u for 4 minus x squared. Alright, so now I can take this, find the antiderivative of it, and then evaluate it. So this is going to become -1/2 times 2/3 u to the 3/2 power, and we're evaluating it now from 0 to 4 because we're leaving this in terms of u. Or I can cancel some things, and that's -1/3 u to the 3/2 from 0 to 4. Alright, so doing that is going to give me -1/3 4 to the 3/2 minus -1/3 0 to the 3/2, and as we can see, that goes away, and so this last piece is our area, which equals -1/3 the square root of 4 cubed. That's that, which 4 cubed is 64, and the square root is 8, so we get -8/3, but remembering we're going to absolute value it, so we get 8/3. So in other words, if we go all the way back up to our picture, we're saying that that area right there is 8/3. Because this is symmetric, then from -2 to 0, the same area would be on this side from 0 to 2, which would be 8/3, and we add the two pieces together, and we get our total area 16/3.